Supercomputers are the most powerful computers in the world. They are used for a wide range of computationally intensive tasks, such as weather forecasting, climate research, oil and gas exploration, and molecular modeling. Supercomputers are also used in national security applications, such as nuclear weapons design and cryptography. Here are some of the important components of a supercomputer. Central Processing Unit. The CPU is the brain of the computer. It performs the calculations that are required to run programs. Supercomputers typically have multiple CPUs, which allows them to perform calculations much faster than traditional computers. Memory. Supercomputers have a large amount of memory, which allows them to store large amounts of data. This is important for tasks such as weather forecasting and climate research, which require large datasets. Storage. Supercomputers also have a large amount of storage space, which allows them to store large amounts of data. This is important for tasks such as storing the results of simulations and experiments. Networking. Supercomputers are typically connected to a high-speed network, which allows them to share data and resources. This is important for tasks such as running large simulations and collaborating on research projects. Supercomputers are important because they allow scientists and engineers to solve problems that would be impossible to solve on traditional computers. For example, supercomputers are used to forecast weather, model climate change, explore oil and gas deposits, design new drugs, simulate nuclear weapons, crack encryption codes. Supercomputers are also used in a variety of other fields, such as manufacturing, transportation, and financial services. As technology continues to advance, supercomputers will become even more powerful and will be used to solve even more complex problems. Here are some examples of how supercomputers are being used today. Weather forecasting. Supercomputers are used to run complex simulations of the atmosphere. These simulations can be used to predict weather patterns days or even weeks in advance. Climate research. Supercomputers are used to model the effects of climate change. These models can be used to predict how the climate will change in the future and how these changes will impact the planet. Oil and gas exploration. Supercomputers are used to find new oil and gas deposits. These simulations can be used to identify areas where oil and gas are likely to be found. Drug discovery. Supercomputers are used to design new drugs. These simulations can be used to predict how drugs will interact with the human body. Nuclear weapons design. Supercomputers are used to design nuclear weapons. These simulations can be used to predict the yield and effects of nuclear explosions. Cryptography. Supercomputers are used to crack encryption codes. These codes are used to protect sensitive information, such as financial data and government secrets. As you can see, supercomputers are used in a wide range of important applications. They are essential for scientific research, national security, and many other fields. As technology continues to advance, supercomputers will become even more powerful and will be used to solve even more complex problems. The cost of supercomputers varies depending on the type and performance. The world's most powerful supercomputers may cost $5-7 million, but there is a gradual rise of affordable alternatives that bring similar performance at lower costs, often as little as $10,000. The largest and most powerful supercomputers can cost tens of millions of dollars to run each year.